Hello everyone, myself Swapnil Sir and welcome to complete lecture series on JEE CET previous year question paper. Already I have uploaded plenty of the videos based on all the syllabus from JEE and CET. Within that I explain complete recap videos along with some of the important topics I already given in my previous lecture. So if you are interested to see this video, do check in my playlist. Now in my today's video, I'm gonna explain to you all some of the previous year question from the JEE and CET type of the questions. So the question I selected here for our today's lecture, which are the all latest questions from JEE and CET previous year question paper. So before we start the lecture, so I wanted to explain here some of the basic concept, basic recap, which we needed for our these examples. Okay. Now, without further ado, let's get dive into our today's lecture. First of all, I'm going to explain to you all some of the basic concept and then we move for our regular previous year question solving. Okay, now let's start. Okay, now before I start the lecture, I just wanted to explain to you all. Already I have explained here the differentiation, first principle of a differentiation, types of the differentiation, composite type of the differentiation. These all topics I already explained in my previous lecture. Okay, so first principle, what the actual first principle it says that when we have limit as h tends to 0, f of x plus h minus f of x completely divided by h, okay, and which is equal to f dash of x, which we call the first principle of our differentiation. Okay, whatever the rate of change of quantity it is coming, we used to find that quantity by using first principle of our differentiation. Okay, so we consider it as the first principle for differentiation. Okay, now see that in most of the case what happen, we don't have to use first principle everywhere, because for finding the differentiation of some of the function like a cos x, trigonometric function, inverse trigonometric function, these are time taking. Okay, so for that we just have to remember directly some of the standard formulas. Okay, so that's one here for the first principle of our differentiation. Now for there are some another types for finding the differentiation, like a parametric type of differentiation, implicit type of the differentiation. Okay, using composite type of the differentiation we deal these conditions. Okay, so first we are going to understand here logarithmic type of differentiation. Logarithmic type of a differentiation. Okay, after that, second, parametric type of differentiation. Parametric type of differentiation. Okay, then after next, implicit type of differentiation. Implicit differentiation. Okay, and there are many other types too. Okay, so for finding this differentiation, we need the form of a composite differentiation. So composite differentiation, it says that composite differentiation, it said that when we have function in the form of y. Okay, now the involvement of a function of y with respect to x, it is also there, and with respect to x, which is y, also there, like a function under function. Okay, then we use here composite type of the differentiation. Now let's go for the differentiation. For finding the differentiation, differentiate our function with respect to x. So we get it here, dy by dx, which is equal to differentiation of x with respect to x. So we get it 1 here. So our value which is equal to dy by dx, which is equal to 1. Now this one is the differentiation of y, which is equal to x. Okay, so this type of the differentiation we are going to learn here in our logarithmic differentiation, parametric differentiation, and implicit type of the differentiation. Okay, now see that for logarithmic differentiation we have to apply some of the results from logarithm chapter. Okay, like a exponent rule. Okay, like the rule for multiplication, addition, and subtraction. Okay, so these types of the rule we have to use here for finding the differentiation. Okay, in most of the case, why we use the logarithmic differentiation? When we have function under function, function to the power function, okay, and function divided by function, okay. If these forms are quite complicated, to deal such a forms, we use a logarithmic differentiation, okay. Now first, for example, if I have f of x to the power g of x, okay, f of x to the power g of x means function to the power function, okay. For finding the differentiation of this function to the power function, it's quite confusing, okay. For this, what we do, we apply log for our both side. So our function, if I consider y of x which is equal to f of x raised to g of x, by applying logarithmic concepts, we write log of y of x which is equal to log of f of x raised to g of x, okay. So then by exponent rule, we take their power as a multiplicand. So we write this one as g of x into log of f of x, okay. So this one is the actually exponent rule for our given function. So this one is the involvement of exponent rule. There are some other rules too. So we are going to see these rules while examples are coming, okay. So this one is here for the logarithmic differentiation. There are some another rules too. So we are going to learn these ones as the later part of our lecture, okay. Now in our next part, parametric type of the differentiation. Now see that till the moment we have learned for finding the differentiation of a given function with respect to x, with respect to y, like a differentiation of any function, okay, differentiation of f of x with respect to x, okay, or with respect to y. So we learn this differentiation with respect to x and y. But when we have given function f of x and we want the differentiation of f of x with respect to g of x, so we have function f of x and we want the differentiation f of x with respect to g of x. In such a condition, we have to apply parametric type of the differentiation, okay. Now for example, let me consider one example here, y which is equal to tan of theta and x which is equal to consider sine of theta. And if we want the dy by dx, if we want dy by dx, in this condition, we have to use the parametric type of the differentiation. Now see that if you are going to differentiate tan theta with respect to x, now see that tan theta is a completely constant term with respect to x, so obviously it will be the part of a constant term, okay. So and that differentiation it goes to 0, so it's not the right way for finding the differentiation for our tan theta with respect to x. So if we have two different function y and x and we want the differentiation of dy by dx, simply you have to differentiate y with respect to theta and x with respect to theta and take their reciprocal. So our differentiation, it comes as a dy by dx which is equal to dy by d theta upon dx by d theta, okay. So this one is our standard parametric form for our differentiation, okay. The remaining part we see in our next part of the lectures. Okay, now let's start our today's lecture with some of the previous year questions from JEE and CET question papers. Now see that question I have taken from MHT-CET 2022 board, MHT-CET 2022 previous year question. Okay, now and in our example we have given x which is equal to e to the power x divided by y. Okay, so what we have given function, our given function x which is equal to e to the power x divided by y here, okay. And what we want here, we want the value for dy by dx, okay. So we want the value for dy by dx. Now just we have to differentiate our given function with respect to x. Now see that we want the dy by dx means we have to differentiate our function with respect to x. So now see that directly differentiation of our given function is quite difficult. Okay, so because function to the power function it is given, okay, like e to the power x by y given, that means function to the power function is given. So in such a condition, we have to apply logarithmic type of differentiation. So in logarithmic differentiation means we just have to simplify our given equation or given function using some logarithmic identities. Okay, so apply log to the both side. Apply log to both side. So log of x which is equal to log of e to the power x divided by y. Okay, so what I have done, I applied log here as well as to the log other side. Okay, so log of x which is equal to log of e to the power x divided by y. So by applying exponent rule for logarithm, take that x by y as a part of multiplicand. So next step, log of x which is equal to x divided by y into log of e. Okay, log of x divided by into log of e. Now see that what I have done, I applied exponent rule for logarithm. Okay, so if we have what the exponent rule, it says if a to the power x which is equal to b, and when we apply log to the both sides, so log of a to the power x which is equal to log of b. Okay, so by exponent rule that x can be the part of multiplicand. So x into log of a which is equal to log of b. So this one is the exponent rule. Okay, exponent rule for logarithm. This one is the exponent rule for logarithm. So I applied that rule here. Now we know that log of e means we write log to the base of e of e. Okay, and log to the base a of a, we know that the value which is 1, or any log term it come across with the exponential term, it gives always the value 1. Okay, so log e which gives us the value 1, so we write our term log of x which is equal to x divided by y into 1. Why 1? Because log of v having value 1. So take that y to the other side. So next step y into log of x, y into log of x which is equal to x. Okay, now see that this one is the simplified form of our given function. Okay, our function given in our example, x which is equal to e to the power x divided by y. So I written this function by using logarithmic identities, y into log x which is equal to x. Okay, and now go for the finding their differentiation directly, because as we want the value for dy by dx, differentiate our function with respect to x directly. Okay, like it's like an implicit type of the differentiation. So differentiation of y with respect to x, now see that we have two different function first multiplied by function second. So first into second, then we apply by part rule for the differentiation, like a differentiation of d by dx of u into v. Okay, by part rule for differentiation. What it says that first function as it is, differentiation for second function plus second function as it is, differentiation of first function. Okay, so this one is a by part rule for differentiation. So apply this rule here. So first function, keep y as it is, differentiation of log x which is 1 upon x, plus log x keep as it is, second function, differentiation of y which is a dy by dx. Okay, as we want the value for dy by dx, so we have to take the differentiation of y with respect to x, so which is a dy by dx which is equal to differentiation of ax which goes to 1. Okay, now take the remaining term to the other side and keep dy by dx at one side. Okay, so next step, it gives us dy by dx into log x is there, log x into dy by dx which is equal to minus of y divided by x. Why minus of y divided by x? This positive term taken to the other side which is a minus y by x, and plus 1 keep as it is. Okay, so next step, log x also take it to the other side, so we get the dy by dx which is equal to minus y divided by x. Solve this identity, x into 1, so minus y x into 1 plus x, minus y plus x divided by x. Okay, or you may keep that negative sign out of the bracket, and completely divided by 1 upon log x. Now what I have done, I just taken that minus y plus x to the other side. Okay, now dy by next step we write it as the dy by dx minus y plus x, we can write x minus y. Okay, replace their place as positive term, take it front. Okay, x minus y divided by x multiplied by log of x. Now see that which one of the option is given here, x minus y divided by x log x, okay, x minus y divided by x log x, which is given in our option number second, option B, which is true here. Now see that how easy type of the questions are coming in our JEE CET question paper, okay. Now let's move for the next example. In our next example, we have given some inverse trigonometric identity. So xy, which is equal to tan inverse of xy plus cot inverse of xy, and then we want the dy by dx at a point 4, 2, okay, and xy which belongs to real number here, xy which belongs to real number, and the question which asked in 2020 MHT-CET exam, okay. Now let's go for the solution. So we have given function xy which is equal to tan inverse of xy, tan inverse of xy plus cot inverse of xy. This one is our given function, and we want the differentiation of dy by dx. So you can find the solution for this example. There are several another way, okay. So as I felt that we directly have to apply some of the standard form from inverse trigonometric function, like a tan inverse of x plus cot inverse of x, which always gives us the value pi by 2. Okay, let me write the formula first here. We know that tan inverse of theta plus cot inverse of theta, we write it as the pi by 2. Tan inverse of a theta plus cot inverse of theta, which is a pi by 2. Now apply this form directly here. So that means tan inverse of a theta, instead of a theta we have xy here, instead of a theta we have here xy. So replace theta as a xy and substitute the value. So xy keep as it is, because we have to deal only the inverse trigonometric function. Or you may apply directly differentiation of a tan inverse of x as 1 upon 1 plus x square. We will get the answer by using this also. So tan inverse of xy plus cot inverse of xy can be written as pi by 2 only. So I consider here xy as a theta, okay, xy as a theta, and directly tan inverse of theta plus cot inverse of a theta, which gives us pi by 2. Now what we want here, this one is the simplified form of our given function. Our function, it says that xy which is equal to tan inverse of xy plus cot inverse of xy, and the simplified form here xy which is equal to pi by 2. Go for finding their differentiation and find out the dy by dx. Okay. For finding the dy by dx, as we know that x into y, we have two different functions. Okay. Apply by part rule between x and y. Keep first function as it, differentiate second, second as it is, differentiate first. Okay. So first function x as it is, differentiation of y, which is a dy by dx, plus second function as it is, differentiation of x, dx by dx, always it goes to 1, and the differentiation of a pi by 2, which is a constant term with respect to x, so write it 0 directly. And what we want the value for dy by dx, so take all the terms to the other sides. So we write dy by dx, which is equal to minus of y, and x it is multiplicand here, it goes to the part of denominator. Okay, so I got the value for dy by dx, which is a negative of y divided by x. But I want the answer when we consider x is a 4 and y is a 2. Okay, when we consider order pair 4 2 is given, means order pair 4 2 given means the meaning here x which is equal to 4 and y which gives us the value 2. Okay, that means we have the value for x and y. Substitute both these value in our dy by dx, you will get the required answer here. Okay, now substitute it here, dy by dx, which is equal to minus of y divided by x. Minus of y means minus of 2. The value for y, which is here 2, and divided by x, which is 4. So minus of 2 divided by 4, which is a minus 1 divided by 2. So our required answer dy by dx, which is a minus of 1 divided by 2. Okay, so this one is our required answer. Now see that where it is option dy by dx, which is a minus 1 by 2, in our option number A given as a dy by dx, which is a minus 1 by 2. Okay, there are several other way for finding their differentiation. It's completely up to you all which you feel suitable. Okay, so the value for dy by dx, which is a minus 1 by 2, it gives us the directly standard result for our tan inverse of x plus cot inverse of x. Now let's move for the next question. So in our next question, we have given log of x plus y, which is equal to log of xy plus 3, and we want the value for dy by dx. And the question which asked in MHT-CET 2022 previous year question paper. Okay. Now let me write the question first. We have given log of x plus y, which is equal to log of x into y plus 3, log of x into y plus 3, and we want the value for dy divided by dy by dx, means differentiation of y with respect to x, we want it here. Okay, go for directly differentiation of y and x together here. So log of x plus y, which is equal to log of xy plus 3. In our first part we have given log of x, second here log of xy and plus 3. Directly differentiate log of x as a differentiation of log of x, which is a 1 upon x. Go for finding the differentiation. D by dx of log of x, we write next step as a d by dx of log of x plus y. Okay, d by dx of log of xy plus 3. What I have done here, I taken differentiation from both of the side. So d by dx of log of xy plus x plus y, and d by dx of log of xy plus 3. So log of x having differentiation 1 upon x. So 1 upon x plus y, but x plus y we have the combination for two different function. That means we want the value for dy by dx. So differentiate that denominator as a part of next differentiation. So d by dx of x plus y, yes, this one is the next step. In our next differentiation, log of xy having differentiation 1 upon xy. Again differentiation of d by dx of xy, okay, d by dx of xy, and plus constant term do not have any rate of change, so differentiation of a constant term 3, which is a 0. Okay. In our next part, differentiation of x plus y and differentiation of xy is there. Let's go for the next differentiation. 1 upon x plus y, keep as it is. Under bracket, differentiation of x plus y, differentiation of x with respect to x, it gives us the value 1, plus differentiation of y with respect to x, which is a dy by dx, bracket complete. Okay, and in our other side, 1 upon xy, keep as it is. Under bracket, differentiation of xy. Now see that we have two different function. Okay, so apply a by part rule here. Differentiation of xy, first function as it is, differentiation of a second function dy by dx, plus second function as it is, differentiation of first, which is a 1. Okay, differentiation of x with respect to x, which gives us the value 1. So x dy by dx plus y here. Now multiply 1 upon x plus y under bracket, 1 upon xy under bracket here, because we want the dy by dx at the one side and remaining term to the other side. So 1 upon x plus y multiplied by 1, which is 1 upon x plus y, plus 1 upon x plus y into dy by dx, 1 upon x plus y into dy by dx. Okay, again 1 upon xy multiplied by x, so that x cancelled with that x. Okay, so we write it as the 1 upon y dy by dx plus y divided by xy, so we write 1 upon x only. Y can cancel here. Take the dy by dx term at one side and remaining term to the other side. So 1 upon x plus y, keep as it is, minus 1 upon y, this term to the other side, and dy by dx common from here. Okay, so between these two terms, which is equal to 1 upon x minus 1 upon x plus y here. Okay, 1 upon x I kept here, and minus 1 upon x plus y it is here. Go for the cross multiplication and finding their values. So y it is here, y minus x minus y, it is just a cross multiplication like a fractional calculation. Y minus x minus y, completely divided by y into x plus y into dy by dx, which is equal to x plus y minus x divided by x into x plus y. Now see that similar term, cancel it from here. Minus y plus y cancel, minus x plus x cancel, plus x plus y cancel. Okay, so remaining term here, minus x divided by y into dy by dx, minus x divided by y into dy by dx, which is equal to y divided by x here. Okay, take this term to the other side. So we get it here, dy by dx, which is equal to y by x as it is. That minus x by y, it is multiplicand here, so it goes to the part of denominator. So we write minus of y by x here. Okay, so dy by dx can be written as negative common y into y, which is a y square, x into x, which is a x square. Okay, so we have here minus of y divided by x complete bracket square is the part of a dy by dx, and our required answer here, dy by dx, is a minus of y by x bracket square. Now see that which one of the option is here. Option number C. Option number C gives us the dy by dx, which is a minus y by x bracket square. Okay, that's is the solution for our example. I hope you all have understood this solution. Nothing is difficult here. Just need to apply some basic differentiation. You can get the easily answer. And that question asked in latest question, it is from MHT-CET 2020 latest question. Okay, so let's move for the next question. Nothing is there in our solution. Now see that we in our next example we have given two different function. Function x, which is equal to under square root of a to the power sine inverse of t, and a function y, next function given y, which is equal to square root of a to the power cos inverse of t, and then we want the dy by dx. That means we want the differentiation of a first function with respect to another function. Now see that when we come like in such a situation, we apply directly parametric type of the differentiation. And what the parametric type of differentiation says, that the parametric type of the differentiation, it says that if you have dy by dx, for finding their differentiation, we write now function is in the x is in the form of t, y is in the form of t. So that means we want the dy by dt divided by dx by dt. Okay, this one is the differentiation for dy by dx. Okay, with respect to t. So our x function x is given square root of a to the power sine inverse of t. That means function is in the form of a t. That means we have to take the differentiation dx by dt and y as a dy by dt. Okay, as the dy as a part of numerator, so differentiate numerator dy by dt, differentiate denominator dx by dt. Take the value for x and y. Yes, what we have, function x which is equal to square root of a to the power sine inverse of t, and comma y, which is equal to square root of a to the power cos inverse of t. Okay, cos inverse of t. So these are the two we dy by x and y given, and we want the value for dy by dx here. So for finding their differentiation, let's go for differentiating these functions. Now first of all, we want the value for dx by dt, as x is the function of a t. Okay, so differentiate dx by dt. So find out the dx by dt first. Dx by dt, that means differentiation of this square root of x, and we know that d by dx of root x, which is a 1 upon 2 times root x. Okay, so write down their differentiation. 1 upon 2 times root x means root of a sine inverse of a t. Okay, 1 upon 2 times square root of a sine inverse of a t. And as we have here function under function, like a square root of another function here, so differentiate that function after here. So differentiation of a sine inverse of a t, it is there. Okay, d by dx dt of a sine inverse of t. Okay, a sine inverse of t. This one is the differentiation. Let's go for finding the differentiation of a sine inverse of a t. Okay, so this is the involvement of inverse trigonometric function, and we know that sine inverse of a t having differentiation 1 upon square root of 1 minus t square. Okay, now substitute the put the value for this differentiation. Dx by dt can be written as 1 upon 2 times square root of a sine inverse of t, a sine inverse of t, which multiplied by, keep a as it is, sine inverse of t having differentiation 1 upon square root of 1 minus t square. Okay, this one is the differentiation for a sine inverse of t. First part I kept it as it is, no need to solve this term, keep as it is, because as we have the part of numerator dy by dt, so we can cancel these terms. So in our next step, differentiation of y with respect to t. So dy by dt, that means d by dt of square root of a cos inverse of t, a cos inverse of t. Now differentiate root x, which is 1 upon 2 times root x. Okay, differentiation of root x, which is a 1 upon 2 times root x. So 1 upon 2 times square root of x means square root of a cos inverse of t, a cos inverse of t, differentiation of a root x, which is a 1 upon 2 times root x. Okay, so a cos inverse of t, which multiplied by d by dt of differentiation of a cos inverse t. It is a composite type of the differentiation, a cos inverse of t. So differentiate a cos inverse of t further. So keep first part as it is, dy by dt, we'll get it here, dy by dt, which is equal to 1 upon 2 times square root of a cos inverse of t multiplied by, so a constant keep as it is, differentiation of a cos inverse of t, which is a minus 1 upon square root of 1 minus t square. Okay, that means minus a upon square root of 1 minus t square, which is the differentiation of a cos inverse of t. So I found the value for dx by dt, as well I found the value for dy by dt. Okay, so this one is the value for dx by dt here, and again we have the value for dy by dt. For finding the dy by dx, apply parametric type of the differentiation. Okay, now what we want here, dy by dx, and dy by dx can be written as dy by dt upon dx by dt. So dy by dx can be written as dy by dt. So what is the value for dy by dt, which is a 1 upon square root of 2 times a cos inverse of t, a cos inverse of t multiplied by minus a upon square root of 1 minus t square. Okay, this is the value for dy by dt, and completely divided by dx by dt means take their reciprocal, then numerator is the part of denominator and denominator it is the part of numerator. Okay, or you may take directly division, because we have to cancel the terms here, and completely divided by dx by dt, substitute the value 1 upon square root of 2 times a sine inverse t, yes, a sine inverse of t, and multiplied by minus a, multiplied by, sorry, a it is there, a upon, multiplied by a upon square root of 1 minus t square. Okay, this one is the differentiation for dy by dt, and this one is for dx by dt. I substitute these values here in our parametric differentiation. Okay, now see that those are the possible term, cancel it. So minus a upon 1 minus t square, a upon 1 minus t square, we can cancel these two steps. We cancel this one with this one. So numerator, it goes to the dy by dx, which is equal to, dy by dx can be written as minus of a minus 1. Okay, minus 1, a cancel it, the denominator a, minus 1 upon 2 times square root of cos inverse of t, cos inverse of t. Okay, this one is the part of numerator, And as the part of denominator, we write it is here 1 upon 2 times a sine inverse of a t. So denominator of a denominator is goes to the numerator. So multiplied by 2 times a sine inverse of a t, a sine inverse of a t. Okay. Now see that that 2 cancelled with this one. So dy by dx, the term left here, negative of, now see that a sine inverse of a t, a sine inverse of a t having value x, reverted back. So minus of x and a cos inverse of a t. A cos inverse of a t is there. So a cos inverse of a t, which is having value t here. Okay. So it's a to the power sine inverse of a t is the result we have here. Okay, a to the power sine inverse of a t. Yes, and let's go for finding their values here. So dy by dx we have here minus x, dy by dx which is a minus x, and as a part of denominator a cos inverse of a t means value for it is here as a y. Okay, so dy by dx gives us the value negative of x divided by y, which is our required answer here. Okay, I hope you all have understood. It's just a simple parametric differentiation. I need to apply some of the basic results from our differentiation. Okay, I hope you all have understood. Let's move for the next question. In our next question, we have given function y of x which is equal to cot inverse of square root of 1 plus sin x plus square root of 1 minus sin x upon square root of 1 plus sin x minus square root of 1 minus sin x. Okay, so we have to simplify this step first. And our x means theta given in the interval of pi by 2 to pi. Okay, and then we want the value for dy by dx at x which is equal to 5 pi by 6. Okay, at point x which is equal to 5 pi by 6. Now first of all, let's go for finding their differentiation. Let's go for finding their simplified form of our given function. Okay. Okay, so what we have given here, square root of 1 plus sin x. Now as we observe here, square root of 1 plus sin x can be written as, okay, square root of 1 plus sin x can be written as cos of x by 2 plus sin of x by 2. Okay, under modulus cos of x by 2 plus sin of x by 2. This one is the value for square root of 1 plus sin x. Again, if we take the modulus square root of 1 minus sin x, 1 minus sin x, which can be written here under modulus cos of x by 2 minus sin of x divided by 2 here. Okay, now substitute both of these values in our y of x, you will get the required values here. Okay, now substitute the values. So y of x can be written as, keep cot inverse as it is. So square root of 1 plus sin x, which can written as modulus of cos x by 2 plus sin x by 2. Okay, cos x by 2 plus sin x by 2. This one is the square root of 1 plus sin x plus square root of 1 minus sin x. It also can be written as modulus of cos x by 2 minus sin x by 2. Okay, this is just the substitution of a value. So I applied here this one, this standard formula. By using this standard formula, I got these values. Okay, now as the part of denominator, cot inverse of given function. Okay, square root of 1 plus sin x, substitute the value cos of x by 2 plus sin of x by 2. Okay, under modulus. Okay, plus given as the part of negative. Okay, so denominator here, negative here, so which is a negative under modulus square root of 1 minus sin x having value cos x by 2 minus sin x by 2. So cos of x by 2 minus sin of x by 2 here. Okay, now expand this modulus and let's go for solving under modulus term. Okay, in our next step we write y of x which is equal to cot inverse of under modulus. Now see that expand this part of denominator, cos x by 2 plus sin x by 2, keep as it is. We cannot change because all the positive term under modulus, it doesn't affect. Okay, so keep these terms as it is. Let's go for expanding next part of the modulus, cos x by 2 plus sin of x by 2. Okay, so now see that under modulus cos x by 2 minus sin x by 2, which gives us the value minus cos x by 2, okay, plus sin x by 2. So this one is complete. Now as the part of denominator, so it is a plus sin x by 2, not a minus, because that the under modulus it changed their signs. Now as the part of denominator, we write cos x by 2 plus sin x by 2, keep as it is, cos x by 2 plus sin x by 2. This is just the basic calculations here. So cos x by 2 plus sin x by 2. Again, expand this next part. So minus of cos x by 2 minus of sin x by 2. So we write here minus of minus, which goes to the minus sin x by 2 here, which is minus sin x by 2, and a cos x by 2, which is the positive term here, cos of x by 2. Now see that similar term, go for cancellation. Minus cos x by 2 plus cos x by 2 cancelled. After that plus sin x by 2 minus sin x by 2 cancels. So our left term here y of x, which is equal to cot inverse of sin x by 2 plus sin x by 2. 2 times sin x by 2. 2 times sin x by 2 completely divided by cos x by 2 plus cos x by 2. 2 times cos of x by 2 here. Okay. So 2 can cancel here. So y of x, which is equal to cot inverse of sin x by 2 upon cos x by 2, which is a tan of x by 2. So our next step, y of x can be written as cot inverse of a tan of x divided by 2 here. This is the value for y of x, which is a cot inverse of a tan x by 2. Now see that we have to find out the value for tan x by 2, cot inverse of a tan x by 2. As we already applied one standard result for cot inverse of x plus tan inverse of x, which gives us the value pi by 2. Okay, cot inverse of x plus tan inverse of x, which is equal to pi by 2 here. So cot inverse of x plus tan inverse of x is a pi by 2. So we have given cot inverse of x. So find out the value for tan inverse of x then. Then we write cot inverse of x, which is equal to pi by 2 minus tan inverse of x. So cot inverse of x can be written as pi by 2 minus tan inverse of x here. Okay. So this one is the value for cot inverse of x. And instead of x, we have tan of x by 2. Replace this value. So y of x can be written as cot inverse of x, which can be written as pi by 2 minus tan inverse of x. Okay, minus tan inverse of, and instead of x we have tan of x by 2. Okay, so which is the pi by 2 minus tan inverse into tan, it gives us the only x, our given theta, so which is a x by 2. So y of x, which is equal to pi by 2 minus x by 2, our given function. Okay, so we got the y of x. This one is the simplified form of our given function. Okay, y of x, which is equal to pi by 2 minus x by 2, and we want the value for dy by dx. So differentiation of y with respect to x. Let's go for finding their differentiation. As we know that pi by 2, it is a completely constant term. So it gives us the value 0. So y of x, which can be written as differentiation of pi by 2, which is a 0, minus of x by 2 having differentiation. Let me write it again. So which is equal to pi by 2 having differentiation 0, minus of x by 2 is the differentiation of minus 1 by 2 common, and differentiation of x with respect to x, which is 1. So which is a minus 1 by 2. So I found the value for y of x, which is a minus of 1 by 2. This one is our required value for y of x. But in our question, it's not the only y of x, which is the dy by dx here, okay, d of y of x by dx. It is the differentiation of y of x with respect to x, okay. So y dash of x, I get the value which is a -1 by 2, and we want the dy by dx at a point. At what point we want? X which is equal to 5 pi by 6. 5 pi by 6, okay. So we want the value for dy by dx at x which is equal to 5 by 6. But as we have y dash of x which is a completely constant term, that cannot affect which our given x which is equal to 5 pi by 6. So our answer, it remains same. So our y dy by dx, it remain only minus of 1 by 2. This one is our required answer, okay. dy by dx which is the -1 by 2 given in our option number C here, okay. Given in our option number C. So this one is the option C correct, okay. I hope you all have understood. Just basic concept we have to apply here for finding the differentiation. Let's move for the next question. In our next question, we have given function f of x which is equal to modulus of x minus 3, and another function which given x square by 4 minus 3x by 2 plus 13 by 4. So two different function it is given. So first function, it is a modulus function. Okay, and modulus function which gives us the value for modulus function x greater equal 1. That means the value for x which is coming from this modulus, which is x greater equal 1, means the value for x possess here 1, 2, 3, 4 and so on, okay. So when we consider the value for x which is a 1, 2, 3, 4, then we have to use the function f of x which is equal to modulus of x minus 3. And in our second function, we have given a simple polynomial function which is x square by 4 minus 3x by 2 plus 13 by 4, and where x strictly less 1, okay. And if x strictly less 1, that means the value for x we consider here 0, -1, -2, -3 and so on. Means the meaning for our example we have here, whenever we consider the value for x 0, -1, -2, -3 and so on, that time we have to consider f of x as a x square by 4 minus 3x by 2 plus 13 by 4. That means for checking continuity and differentiability of our function, we have to consider f of x as this function, okay. And for continuity and differentiability of our function, using the value for 1, 2, 3, 4, we have to consider this modulus function, okay. And we know that a polynomial function, it is always continuously differentiable in its domain, okay, in its domain. And modulus function, it always gives us the peak point in our graph, okay. So whenever it goes to the origin or touches to the axis, the function, it is not differentiable at that particular point, okay, because it gives the peak point over there. So function, it is not differentiable at that particular point. But the point we have given here for modulus of x minus 3, which is a 1, 2, 3, 4, which is other than origin. So maybe our modulus function which is a differentiable for that point, or maybe it is not, okay. Let's verify whether the function it is differentiable or not. Now as we observe here, continuity of our given function at x which is equal to 1, differentiability at x which is equal to 1, and again continuity at x which is equal to 3. Now see that we have the value for x which is equal to 1, x which is equal to 1 and x which is equal to 3. Now see that where all these values lying? Here 1, 2, 3. That means we have to take care of only modulus of x minus 3. So our function here f of x which is equal to modulus of x minus 3, and where x greater equal 1. That means we have to check continuity and differentiability of our function with only that f of x, okay, with only this f of x. Because second f of x, it is not useful here, because we do not have any point smaller than 1, okay, as a continuity and a differentiability. So we have to check it only the continuity and differentiability for modulus of x minus 3 for x which is equal to 1, x which is equal to 1 and x which is equal to 3. Now let's verify continuity and differentiability. So before I explain this solution, let me explain what is the meaning for continuity and differentiability. Continuity, it says that function f of x at that particular point, which is equal to positive limit of that particular point, negative limit of that particular point. If all these values are coming equal, then we say that function it is continuous. Okay. So what is the definition for continuous function? When we have f of 1. Now as we are checking x which is equal to 1, so take f as a 1 plus positive limit for f again, which is equal to negative limit for f, and which is equal to f of 1. Okay. If this condition hold, then we say that our function is a continuous. Okay. Our function is a continuous when this condition hold for x which is equal to 1. Okay. And similarly we have to check for x which is equal to 3. This is the only condition for continuity of a function. Okay. So f of 3 plus which is equal to f of 3 minus which is equal to f of 3. If this condition hold, then we say that our function which is continuous at point x which is equal to 3. Okay. Our function which is continuous at point x which is equal to 3. Now let's go for the verification whether our function which is continuous or differentiable for x which is equal to 3 or 1. Okay. 3 and 1. Now let's verify for x which is equal to 1 our function it is continuous or not. And to verify our function which is continuous or not, we have to just deal f of x as a modulus of x minus 3. Okay. So we have to check f of x as a modulus x minus 3 at a point x which is equal to 1 and at a point x minus x which is equal to 3. Now substitute x is equal to 1. Now positive limit and negative limit both are same here, because as we have interval x greater equal 1. Okay. That means x started from 1, but there we don't know what is the highest value for our function. Okay. That means we can take it as the infinity. That means we don't have highest value. So that's why positive limit for our function, negative limit for our function, both are coming equal here. Okay. So as we take as we are checking for x which is equal to 1, then we put only directly f of x which is equal to 1 minus 3 which is a modulus of negative of 2. So it always gives us a 2. That means when we consider x is a x which is equal to 1, okay, we got the 2. Again f of x which is equal to 1 plus, check it out what we get, 1 minus 2 again which is equal to modulus of minus 2 which gives us 2. Again for negative limit of f of x which is equal to 1 minus, okay, f x which is equal to 1 minus modulus of 1 minus 2 which gives us a modulus of minus 2 which is equal to 2. Okay. Now see that f of negative limit, f of positive limit our and equal to f of our given point. All these values are coming equal. If all these values are equal, then we say that function which is a continuous at a point x which is equal to 1. Okay. Now similarly do check it out for x which is equal to 3. That means positive limit at x which is equal to 3, negative limit of at x which is equal to 3, and at point x which is equal to 3 we have to verify function which is continuous or not. Okay. That means substitute the value directly here, f of x which is equal to 3, f of x which is equal to 3 minus, and f of x which is equal to 3 plus. Verify whether all the points are given equal values or not. Okay. So f of x which is equal to 3 means modulus of a 3 minus 3 which is equal to 0. 3 minus means negative limit of a 3 which is a 3 minus 3 also goes to 0, and positive limit of a 3 which is a 3 minus 3 which is equal to 0. Now see that all the values for f of x at x which is equal to 3 and the all value for f of x at x which is equal to 1, both are equal here. Okay. Both values are coming equal, and if all are the equal, then we say that our function which is a continuous at x which is equal to 3 and continuous at x which is equal to 1. Okay. Now we have to verify whether it is a differentiable at x which is equal to 1 or not. Okay. Obviously it is a differentiable. Directly we have to apply the limit as h tends to 0, f of x plus h minus f of x upon h at a point x which is equal to 1. x which is equal to 1, you can get the easily our function is a differentiable. Okay, that means in the interval of a modulus of x minus 3, now see that if we go through the graphical, so x which is equal to 3 here, so their graph it is coming here, and we want the value for x which is a 1 or bigger than 1. Okay, that means we are taking only the value which not intersecting our x-axis. That means there do not have any peak point. That means our function is a differentiable for that particular point. So our function is a differentiable for at x which is equal to 1, at x which is equal to 1. Okay, so I hope you all have understood. Or if you wanted to verify by the definition of a differentiability, you can use directly f dash of x which is equal to limit as h tends to 0 f of x plus h minus f of x upon h. Okay, yes, and you have to use as a positive limit x which is equal to 0 plus x which is equal to 0 minus x which is equal to 0. Okay, instead of a 0 we are only taking x tends to 1 here. Okay, h tends to 1 we are taking here. So 0 plus 1 minus and f of 1. Okay, this gives us our function is a differentiable at a x which is equal to. Now see that first option it is true, second also true, third is also true. That means our required answer for our question all of the above. So function is a continuous at x equal to 1, differentiable at x which is equal to 1, and again continuous at x which is equal to 3. Okay, now let's go for the next question. I am expecting that you all have understood this solution. Nothing is difficult here. Yes, in our next function we have given x to the power y which is equal to e to the power x minus y, and then we want the value for dy by dx. What our function given? X to the power y which is equal to e to the power x minus y, and what we want? Dy by dx. We want the value for dy by dx here. Okay, yes, for finding the value of a dy by dx, we can see here x to the power y which is equal to e to the power x minus y. That means function to the power function given. Okay, and when we have function to the power function, we always apply logarithmic type of differentiation. Okay, so apply logarithmic differentiation. Apply logarithmic differentiation. That means apply log to the left side as well as right side. Log of x to the power y which is equal to log of e to the power x minus y here. Okay, so what I have done basically, I applied log to the both side. Log of x to the power y, I use the exponent rule for differentiation. So take y from here, y into log of x which is equal to x minus y into log of e, and we know that log of e means log to the base e of e having value 1. So log and e gives us the value 1. Our left term here, y into log of x which is equal to x minus y here. Okay, y into log of x which is equal to x minus y. Now what do we do in our next step? We go for finding their differentiation with respect to x. Okay, so take the term at one side x minus y and then find out their differentiation. Okay, so in our example I found this one is the simplified form for our differentiation, which is a y log x which is equal to x minus y here. Okay, then find out the value for y, so we can directly differentiate it as a dy by dx. Okay, for finding the value of a y, we write y which is equal to x minus y divided by log of x, or you may take a y to the other side also. Okay, y to the other side, take y common and then find out, because if you go for finding differentiation, then after that you have to arrange the term. So instead of arranging the term, directly find out their differentiation. Okay, let's arrange the term first. Okay, minus y to the other side, y log of x, keep as it is this term, minus y to the other side which goes to the plus y, and remaining side x here. Okay, take y common from here, log of x plus 1 which is equal to x, y keep as it is, x divided by, take this term to the other side, log of x plus 1. This one is the value for our given function y of x. Okay, y of x can be written as x upon log x plus 1 here. Okay, now we want the differentiation of our function with respect to x. Now find out the dy by dx. For finding the dy by dx of our given function, we have to apply here the quotient rule for differentiation. Like a differentiation of u by v can be written as v into differentiation of u minus u into differentiation of v divided by v square. Okay, let me write the quotient rule for differentiation. D by dx of u by v. Okay, u by v can be written as v into du by dx minus u into dv by dx upon v square. Okay, this one is our required quotient rule for finding their differentiation. Okay, apply directly here. Okay, so dy by dx can be written as, okay, v into derivative of u, that means log of x. Okay, log of x plus 1, log of x plus 1 into a differentiation of x with respect to x, it gives us the value 1 minus v x as it is, log x having differentiation 1 upon x and plus 1 having differentiation 0. Okay, so our next step, log x plus 1 minus x by x into 1 by x and a v square, that means log of x plus 1, okay, the bracket, entire bracket square, okay, v square here. Now see that x can be cancelled, so dy by dx can be written as plus 1 minus 1 cancelled, so log of x completely divided by 1 plus log of x bracket square. Okay, log of x upon 1 plus log of x bracket square. Now see that in our option number D, we have given, okay, see that our option D, in our option D we have given required answer. Okay, so this one is our option D correct here in our example. Okay, now let's move for the next example. This one is the last example for our today's lecture. I have taken most of the example from latest previous year question paper. Okay, so in our next example we have given y which is equal to cos square of 5x by 2 minus sin square of 5x by 2. As we can see this example, we can come to understand that it is quite complicated type of the differentiation. But don't worry about that. Actually, in actual, it is not that difficult. We have to apply some standard result from trigonometry. We have to simplify our given function. Then you have to go for the directly differentiation. Okay. So in our function, what we have given? Y which is equal to cos square of 5x divided by 2 minus sin square of 5x divided by 2 here. Okay. And we want the value for d square y by dx square. That means the differentiation of y with the twice. Okay, that means twicely we have to differentiate our given function. So what we have here, y which is equal to cos square theta minus sin square theta, y which is equal to cos square theta minus sin square theta given. Okay, and as we know that cos square theta minus sin square theta can be written as cos of 2 theta, which is a very much important result here in our mathematics. Cos 2 theta can be written as cos square theta minus sin square theta. There are some another form for cos 2 theta, like a 2 cos square theta minus 1 minus 2 sin square theta, and a cos 2 theta can be written as 2 cos square theta minus sin square theta. Okay, so this one is the expansion for actually cos 2 theta. Now go for substituting y which is equal to cos of 2 times theta means 5x divided by 2 here. Okay, let me write this one again. 5x divided by 2 is there. Okay, not a 2x, 5x divided by 2. Now see that 2 can be cancelled with the 2. So we found the simplified form of y which is equal to cos square of 5x by 2 minus sin square of 5x by 2 as a cos of 5x. Okay, cos of 5x. So this one is the value for y. Now we want the dy by dx, and after one more time double differentiation for y. Okay, so dy by dx can be written as differentiation of a cos of x which is a minus of sin x, so minus of a sine of 5x, and as we have function is like a composite type of differentiation, so we differentiate 5x after this. Okay, so differentiation of 5x, it goes to the 5. Okay, okay, this one is the differentiation for dy by dx. After go for finding the another differentiation d square y by dx square. That means we have to differentiate our minus 5 sine 5x one more time. Okay, so my negative cape as it is, sine 5x having differentiation which is a cos of 5x. Okay, and the differentiation of 5x later on, because it is a composite differentiation which gives us the 5, already 5 constant term as it is. So our next step, it gives us a d square y by dx square can be written as 5 into 5, which is a negative of 25, minus already there, and multiplied by cos 5x. Okay, so this one is our required answer, minus 25 into cos 5x. Okay, and but as we know that cos 5x also can be written as y. So d square y by dx square can be written as minus 25y. Okay, so this one is our required solution for our given example, which is our option number C true here. Now see that how easy type of the questions are coming in your JEE CET type of the questions. Okay, so these all are the latest question from your previous year question paper. I hope you all have understood this entire solution. Okay, and now in the last part of my session, I just wanted to explain here what we have done so far. Okay, at the beginning we learned here the first principle for differentiation. Subsequently, I explained here some of the important type of differentiation like logarithmic differentiation, parametric differentiation, composite type of the differentiation, and implicit differentiation. Okay, all this we have learned in our today's lecture. I hope you all have understood everything from my today's lecture. Even if you found anything difficult, let me know in my comment section. I will come up with a similar videos. So if you wanted to learn more concept, if you wanted to understand some difficult concept, let me know in my comment section. I will come up with a similar video. So thank you everyone. Thank you for my today's lecture.